In our last lesson that you watched on EduCanon, you learned about the difference between ionic bonds and covalent bonds, and you also learned about the octet rule. So today we're going to talk more specifically about ionic compounds and how they're formed, how you can predict how they're going to form, and how we name them. In order to get an ionic compound, you first need ions. And there are two kinds of ions. There are ones that have a positive charge and ones that have a negative charge. The ones that have positive charges are called cations, and they are named just based on the name of the element they come from. All of our cations that are single atoms are metals. And so metals, because they're over on the left side of the periodic table, they don't have very many valence electrons, and so they tend to lose their valence electrons in order to have a complete shell. So sodium has one valence electron. If it wanted to complete its shell by gaining electrons, it would have to get 7 more electrons, which is just not going to happen. So in order to be fulfilled by the octet rule, it loses 1 electron. And if the number of protons in the nucleus stays the same, but it loses 1 electron, it loses 1 negative charge. And so that gives the ion that's left a positive charge. And we call this a sodium cation. Simple enough. So if we look at another example, what would you expect to form from an atom of magnesium? So if we look at our periodic table, magnesium is in the second column, or the second group, and it has 2 valence electrons. So in order to have a full energy level, it would either have to gain 6, which is not likely to happen, or it's going to lose the 2 that it does have. So magnesium loses its 2 electrons and forms Mg2+, or the magnesium cation. Negatively charged ions are called anions. And so we have an example here. So if nitrogen has 5 valence electrons and it gains 3 more in order to get to 8, then we call it nitride. So while cations just maintain the name of the metal that they came from, anions take on a new ending when they become an ion. So nitrogen becomes nitride. If you were to make an anion from oxygen, it would be oxide. If you were to make one from chlorine, it would be chloride. So anions always end in IDE. Okay, so what would we expect to form from an atom of fluorine? So if we look at our periodic table, fluorine is in column 7, and it has 7 valence electrons. Okay, so again, it's not likely to lose all 7 of those electrons. So the more likely thing to happen is that it's going to gain 1 more, which is going to bring it from 7 to 8, and so it's going to have a full octet, and that gain of 1 additional electron will give it a -1 charge. So we'll have F minus, and it will be called fluoride. Since we just talked about how we can predict ionic charges from the periodic table, or from the valence electrons, it shouldn't surprise you then that we can use the periodic table to figure out what charge an atom is likely to take on. And so we just did an example from the alkali metals. Sodium is an alkali metal, and all of those have 1 valence electron. So the elements in that column are always going to form +1 cations. In group 2, they always form +2 cations. We're going to skip over the transition metals. You'll see over and over again that they behave very differently than everything else. So we're just going to look at the main group elements for today. In group 3, the only metal in that group that we really do a whole lot with is aluminum, but it forms a +3 because it has 3 valence electrons. Group 4, you'll find because it has 4 electrons, it doesn't really want to lose 4, and it doesn't really gain 4 either. And so what you'll find is things in that column don't tend to form ionic compounds, or the ones down further do, but we'll talk about those later. So we're going to skip that column. The ones in group 5, nitrogen is in group 5, and we said it's going to gain 3 electrons to get to 8, and so that group has a -3 charge. Group 6 has to gain 2 electrons in order to get to 8, so those have a -2 charge. And in group 7, they need to gain 1 electron, and so they all have a -1 charge. And then this last column here, all of the noble gases already have 8 electrons, and so they don't form ionic compounds either. So now just a little bit of a review from what you saw in your video yesterday. Ionic compounds are when we get a transfer of an electron or more than one electron from a metal to a nonmetal, and the result is that you get a cation in the case of the metal and an anion in the case of the nonmetal. And so an ionic bond is actually just based on Coulombic attraction between a positively charged and a negatively charged ion. And it's important to remember that when an ionic bond forms, the ions that you get do not have the same properties as the elements that they came from. So for example, we learned that sodium metal reacts violently when you put it in water. And chlorine, in its elemental form, is a green gas that's poisonous. But if you take both of them and you transfer some electrons and then form an ionic bond, you get a white crystalline solid that we frequently put on our food. And so it is neither poisonous nor highly reactive in water. So the resulting compound that you get when you make an ionic bond or an ionic compound does not have the same properties as the things that you start with in their elemental form. So now let's practice writing some of the formulas for these ionic compounds. So a formula is a shorthand way of us telling how many of each kind of ion is in particular type of ionic compound. And so we use little subscripts in order to show that. And it is important that for ionic formulas, because they form large crystalline structures, we just show the lowest whole number ratio. So a given crystal of salt will have billions of sodium ions and billions of chloride ions. But what we care about is that the ratio is 1 to 1. That NaCl implies that there's 1 sodium ion for every chloride ion that's present. And so in order to write an ionic formula, we need to know the charges of both of the ions that we're starting with. So if we form an ionic compound from potassium and oxygen, for example, if we look at our periodic table, potassium is an alkali metal, and so that means it's going to have a +1 charge, and oxygen is found in the 6th column, so it wants to gain 2 electrons to have a full octet. Okay, so we have K plus and O2 minus. So if we put both of those together, we would have, if we just use one of each, we would have a negative charge left over. All right, so in order to satisfy that -2 for the oxygen, we need 2 potassiums to balance out that charge. So our formula for potassium and oxygen is K2O. So that tells us that we need 2 potassiums, which both have a +1 charge, and 1 oxygen, or 1 oxide ion, in order to get a neutral salt crystal. Now we can do the same thing for magnesium and nitrogen. So magnesium is going to form an Mg2+ ion. It's in the 2nd column. And nitrogen is in the 5th column. It's going to form N3-. So in order to get a neutral charge with these, magnesium has a +2 and nitrogen has a -3. We sort of need the lowest common multiple, if you remember that from math. So if we have 2 magnesiums, then we now have +4 with the nitrogen with a -3. So that's not going to work. So then we need another nitrogen, so that gives us a -6 for the nitrogen side, and we would need 1 more magnesium to satisfy that. So that gives us a formula of Mg3N2. So we can go through these last two a little bit more quickly. So barium is in the 2nd column. It will have a +2, and sulfur has a -2. So a +2 and a -2 balance each other out fine. So our formula for that one is just BAS. And then last but not least, we have sodium, which has a +1. Fluorine has a -1. And so our formula for that is just going to be NaF. And so I now just want to go very briefly over how you name simple ionic compounds like the ones we've dealt with today. So KCl, that would be a compound formed from a potassium ion and a chloride ion. So simple enough, we just put the names of the two ions together. The metal always comes first, so the one that's on the left on the periodic table is also going to be on the left in your name. So this is potassium chloride. Okay, the next one is 3 sodium ions and a nitride ion. It doesn't matter how many there are because we know their charges, so we could take their names and figure out the formula, so we don't worry about that with ionic naming. So this is just sodium nitride. Just put the names of the two ions together. And so the last one is an aluminum ion and 3 fluoride ions, so this is just aluminum fluoride. All right, so that wraps up our basic introduction to ionic compounds. We'll go over some practice for how to do their formulas and their naming for the simple ones tomorrow in class, and then tomorrow evening for your video assignment, we'll talk about a little bit more complicated naming, and we'll also go over naming of covalent compounds.